We're going to do a quick review on interval notation. You started off your math career learning about inequalities. So these four things over here are all called inequalities because they are unequal. They're not equal necessarily. Okay, so this one looks like a squished L. So an L would look like this, and we squished it. Okay, so this is less than. This one is greater than. And then remember, we're lazy math people. So this one is less than, but it can also be equal to. And this one is going to be greater than or equal to. Okay, so what we did, because we're lazy math people, is we took a less than and an equal sign and we squished it together into one symbol. So if we cover up this part, it looks like an equal sign. Okay, if we cover up this part, it looks like a less than sign. So we just squished it together because we're lazy. Okay, so this one is a greater than or equal to. So if I cover up this part, it's equal to. If I cover up this part, it's greater than. So we're just squishing information in. Now what we're going to do is this strategy. Part one is we're going to plot on a number line. So we're going to plot the inequality on a number line. And then we're going to convert, read from smallest to biggest, which is either going to be left to right or bottom to top. Okay, either left to right or bottom to top. The third thing is going to be to convert into interval notation. My pen just died. Okay, convert it into interval notation. So we're going to start with x is greater than 4. So first of all, how many solutions? How many numbers are there that are bigger than 4? Okay, x is bigger than 4. There's an infinite number of numbers that are bigger than 4. So if we slap this on a number line, we would be interested in the number 4, and we would be interested in everything bigger than it. So we either shade, or you may have been taught to use an arrow. Okay, then can we use the 4? No, we cannot. So we used an open circle. What are you actually doing there? What you're actually doing is you're saying, I'm interested in 4. I can use this point, this point, this point, this point, all of these points that are right smack next to each other. But when I get to 4, I cannot use that point. So I zoom in like with a microscope, and I say, I cannot use that point. That's why it's open. Okay, so why don't we just say, well, 4.1? Okay, I can start my answer at 4.1 because there's a number between 4 and 4.1. Okay, what about 4.01? There's a number between 4 and 4.01. What about 4.001? There's a number between 4 and 4.001. So what we have to do is say get infinitely close to, but do not touch. Get infinitely close to, but do not touch. So because we're lazy math people, we usually just end up shading, or like I said, you probably have used an arrow at some point in your life or another. And now we're going to convert. Okay, so come back over here for a second. When we are converting into interval notation, if I cannot use the answer, then I'm going to use parentheses. If I cannot use the answer, I'm going to use parentheses. That includes infinity and negative infinity. Okay, infinity is a concept. It's not a number. So I can get up into infinity, but I cannot say something equals infinity. Okay, if I'm going to use the equals to, then I'm going to use hard brackets. Hard brackets. So how do I tell the difference? This little equal sign, notice that an equal sign is made up of 2 horizontal dashes. So are these. They have 2 horizontal dashes in them. So that tells you which one to use. So now we're going to convert. Come on back over here. You're going to read your answer from left to right. So these are the same graph. I have no answer, I have no answer, I have no answer. Bam, I have an answer. So my answer starts at 4. Your bracket is going to hug the answer. So I've already determined I'm going to use parentheses for this. And I use the parenthesis that hugs the answer. So my answer starts at 4. Do not touch. Approach, but do not touch. Okay? Where does your answer end? Your answer is going to go shooting off into positive infinity because it never stops. All the numbers bigger than 4 are fair game. And the infinities always get a soft bracket. So this is the same representation as this. This is just inequality notation. This is interval notation. So it tells me an interval or the width of something I'm allowed to use. So let's speed it up and try something else. What happens if I have x is less than or equal to -7? Okay, plop it on a number line first. I am interested in -7. I am interested in everything smaller than -7. I want all the numbers that are less than -7. So there's an infinite number of those. Am I allowed to use the -7? Yes, I am. So he would have a filled in circle. Remember, you're zooming in like you're underneath a microscope. So you're looking at that specific point and you're saying, hey, that's fair game. I can use that. So now I need to convert. Where does my answer begin? I'm in my answer. I read it from left to right. I am in my answer. So the infinity to the left is negative infinity. So I'm somewhere in the negative world. Okay. So all the answers in negative infinity, you cannot equal negative infinity. And I'm going to come screaming up to -7. But do not touch. And remember, the arms hug the answer. So this says I've got everything to the left of -7, including -7. Let's try another one. I'm going to change up my variables because I can. I've got 4. Oops. I've got 4 is less than y is less than or equal to 10. Okay, so what does this say? 4 is smaller than y. 4 is smaller. 4 is less than my answer. So I'm going to do 2 things. I've got a number line. I'm interested in 2 numbers, 4 and 10. 4 is smaller than y, which means y is bigger than 4. Okay? So y is everything this direction. Okay? So now I've done this part. 4 is the smallest that y can be. What kind of a bracket will 4 get? 4 will get a parenthesis or a soft bracket. Okay? Because the arms hug the answer. So now what does this say? Y is less than or equal to 10. So let's shade that part. Y is less than 10 or the same thing as 10. So what kind of a bracket will 10 get? He'll get a hard bracket. The overlap is your answer. So where the 2 things overlapped is between 4 and 10. So what is my answer? I can't use this one because it's not bigger than 4. I can't use this over here, or I say this one. I can't use anything over here because it's not bigger than 4. I can't use anything over here because it's not smaller than 10. So what is my final answer? My answer, I cannot use, cannot use, cannot use. My answer begins at 4. Approach, but do not touch. And then I can use everything in here, but I cannot, or I can use 10. So this is the interval notation. What that says is that y is between 4 and 10. Don't use the 4, please use the 10. Let's do a couple more examples. Let's use z. I can say that z is less than 20 and z is greater than 21. And we'll just say or equal to. I'm just making stuff up. Okay, so I'm interested in 2 numbers. I'm interested in 20 and I'm interested in 21. This one says that z is smaller than 20. So I'm going to graph everything over there. What kind of a bracket do I use? I cannot touch the 20, and the arms hug the answer. This says z is bigger than 21. So I need to graph everything over here. Can I use the 21? Yes, because z can be equal to 21. So I'm going to use a hard bracket, and the brackets hug the answers. There's no overlap, but there is this missing chunk. Okay, so I'm going to say what works here and what works here. So where does my answer begin? Negative infinity all the way up to 20. The infinities always get soft brackets. I can approach 20, do not touch. Okay, got nothing in here. Okay, so look at 21. I can use 21 and keep going into positive infinities. The infinities always get parentheses or soft brackets. And then this hugs the answer. Now in math world, we use this shape, which is called union. So the way I read that is union. Okay, now I'm going to do one more example. So what if I have everything? I didn't even put a number. I can use everything. Where does your answer start? It starts out in negative infinity. Keep going, keep going. Where does your answer end? Positive infinity. So this is a way of saying everything works, or all real numbers. Everything works, or all real numbers.